Hello and welcome to our this year's user meeting workshops. This is the workshop for battery simulations for beginners. It's the user meeting 2020 and my name is Ilona Klatt. I'm very happy to go with you through this workshop. First of all, let me introduce our electrochemistry team at Math2Market. On the left-hand side, you can see Dr. Fabian Biebel. Fabian works as a developer and he is responsible for the graphical user interface for the battery charging simulations. On the right-hand side, you can see my colleague, Dr. Matthias Fingerle. Matthias leads the electrochemistry team at Math2Market, which includes mainly batteries and fuel cells. So here we're doing the part of the batteries in this workshop. In the middle you can see myself, Dr. Ilona Klatt. I'm sharing the position of the electrochemistry team lead with Matthias. Funny, but all of us are physicists. Apart from the three of us, of course, there are many more people contributing substantially to the advances in the electrochemistry field at Math2Market. So, for example, there's Sven Linden, who started developing the Lear solver, so a new solver for charging the batteries. And there's also Janine Hilden, who does a lot of the project work in this field. And of course, there are also our colleagues from the Fraunhofer Institute, Jochen Zausch and Jan Lammel, who developed the best solver for the battery charging simulations, and many, many other people working at Math2Market in the electrochemistry team. What are we going to do in this workshop? Well, the workshop consists of 3 parts. Each of these parts lasts about half an hour. After each of these parts, we'll have a 10-minute break. During these breaks, you can ask questions regarding the first part or general geodetic questions, or you can just have a break and grab a coffee or something. Unfortunately, this year we are not able to serve the coffee to you, so you have to do it yourself. In the first part, we will start with importing a 3D scan. In our case, this is a micro CT scan, but it can actually be any tomography scan, 3D scan that you have available. It works the same, so it can also be FIB-SEM scan. In the end, you will usually end up with a 3D image stack consisting of 2D images, and these are always importable into GeoDict. We will import and also visualize this tomography data that we will import and have a look at this in 3D. And then we will also segment the data, so saying GeoDict or telling GeoDict which voxel or which pixel or which part of the image actually belongs to which material phase. In the second part, after the first break, we will run some geometrical analysis on the material. Namely, we will analyze the pore space and the tortuosity. We will see that there are several ways of defining pore sizes or the size of pores in general. All of these are valid definitions, and which of those is most important for you, is the most useful for you, depends on what is your application and what do you actually want to know. Similar thing is true for the tortuosity. There are also several possible definitions of tortuosity, and we will focus here on the tortuosity, which is based on the diffusivity of the material, which is probably the one which is most important in the field of batteries, because the diffusion plays a very important role in operating a battery. Before we go to the next break, we will run some geometrical analysis on the before we go to the next project, we will create a half cell out of the material we have, which we can actually use for charging simulations in the third part of the workshop. So in the third part, we will actually run charging simulations, or it's better to say we are setting up the charging simulations, because the charging simulations themselves, they take quite some time, and they're very demanding for your computer. So what we are going to do is we will set it up, I will show you how to input all the values, and then running the simulations we will skip, and we'll have a look at the results, which I prepared for you before the workshop, and you can find those in the project in the handout folder that we gave to you for the download before the workshop. The simulations we will have a look at, the charging simulations, include, first of all, a fast estimation of the charge curve. This is very useful if you want to get a clue of did you build a good battery, and if it's very promising, you can run a full charging simulation, because that's much more demanding than this fast estimation, and then the 3D simulation of getting the concentration values and so on, that takes more time. We will compare different solvers in the BatteryDict. We now have available a new solver, which is the Lear solver. This might be known to you from other GeoDict modules like DiffuDict or FlowDict, for example. And we still have the good and very well-known solver, the BEST solver from the Fraunhofer Institute, which is still available in GeoDict and will be in the future too. And the BEST solver also has a new nice feature, very important. It can now model the CBD, so the carbon black and binder domain, as a porous phase. So it includes binder, carbon black, and also electrolyte. And in the end, we will compare different charge rates for this one structure we are looking at, and compare these the resulting charge curves. Of course, in the end, you will again have the opportunity to ask questions. The modules we are going to use during this workshop are the Import Geo module, Grain Geo, PoroDict and MatDict, BatteryDict module, and the DiffuDict module for calculating the tortuosity. You can see in grayed out that there are a lot of other possibilities and modules available in GeoDict, which allow you to cover a wide range of applications. So I talked a lot about importing a scan and segmenting it and so on, but what scan are we actually looking at? Well, it's a scan that was taken by the ETH in Zurich of an NMC cathode material. This scan is publicly available from the website of the ETH in Zurich, and you can download it from their website if you want to. Of course, it's also available in the handout folder that we handed out to you before the workshop. And if you want to know more about the scan, you can also go to the publication that is cited here from Ebner et al. The entire scan covers 1,400 times 104,000 times 200 voxels. However, in this workshop, we will only work with a smaller set of this material so that the simulations do run quickly and go smoothly. as we are going to do it live, at least for the 2 first parts of the workshop. The third part, as I said, will be kind of offline, so just preparing and looking at the results. The thickness of the structure, so the 200 voxels, this is just the thickness of the entire cathode. So in that direction, we do not need to cut anything. We are only cutting the X and Y direction to these 500 voxels. When you open Geodict, it looks like this. And I'm not going to explain all the details of the navigation in Geodict right now, because there's a detailed tutorial on that, which is called the Geodict Beginners tutorial. And it's available as a video tutorial. And if you're interested, I can send you the link, and then you can follow it step by step. What we're going to do now first is setting a project folder. Here you can see the current project folder is set to my first Geodict project. This is the default. It's usually located under Documents. And if you right click on that, you get the opportunity to select a project folder. And then I would like you to navigate to the handout material that you got for the workshop. And in the handout material, you will find a folder which is called Project. Choose this one and say choose folder, and then you can see that here the path changed to the project folder that we just chose. In this project folder, Geodict will now store everything that we do if we don't specify it otherwise. All the files that Geodict produces will be stored there. And also Geodict looks for files first in that place. And we're just going to look for a file right now because we are going to import a scan, the cathode scan we already talked about. So please go to the import module here, import GeoVol. Then you can see here that we have the import GeoVol module chosen. You click on Browse, then the project folder opens, and if you go one folder up, you can see that there's the ETH-NMC cathode GRW file located. Please choose that one. This is already a 3D scan. If you want to learn about importing an image stack of 2D images, please go to the image processing workshop. This will be done in detail there, but the principle is exactly the same as for this one. It's just a little bit more prepared so that you don't have to do all the steps, and we can focus on the analysis later on. So please click Open. Then this dialog here opens, and you can see that, for example, you get the size of the scan, which is 1,400 voxels in X direction, 1,400 voxels in Y direction, and 200 voxels in Z direction, as we already saw in the PowerPoint before. You could already crop the scan here, but we want to see or have a look at it in its full size, so we don't crop it yet. You can see that the voxel length is at the moment set to 317 nanometer. If you want to see it in nanometer, here it's micrometer, but if you want to see it in nanometer, you can also choose to see it in nanometer. So now here you can see 370 nanometer. Then there's also a header size, which does not need to concern you at the moment. It's only necessary for Geodict to know where to start reading with the actual data. So now we want to start with the image processing. So click on that. And you can see that there the image processing dialog opens. Before we have a look at this dialog, please minimize that so that you can see the main window of Geodict again. And you can see that now in Geodict 2021, automatically the gray value image in 3D is being visualized. So here you can see just the scan. You can turn it around, as you can always navigate in Geodict with your result fields or also the structure. You can zoom into this by turning the mouse wheel and just have a closer look at your scan, or zoom out. By clicking onto the mouse wheel and holding it, you can move it from left to right or right to left. And you can, of course, also, if you go to the volume field tab, you can also clip the gray values. You can see that there are several different gray values, of course. So the darker ones are representing the pore space, while the lighter ones represent the actual solid material, in this case the NMC material. So if you turn the slider here to the right, you can see that at a certain value the darker spots start vanishing and we can only see the lighter spots. Oops, can play around a little bit with that. So this helps you visualizing your gray value image, and you can also store these the visualization as an image if you want to, just as you always do in Geodict. Now let's go back to the import main window, and let me explain a little bit what you see here, because this is has changed a lot since Geodict 2020. So this is Geodict 2021. The general overview is the same. What you see here is the XY plane of the image, and here you see the ZY plane of the image and the XZ plane of the image. So you can look at each at the scan in each direction. You can scroll by turning the mouse wheel through the scan in each direction. So here on the in the ZY plane you can see the XY plane moving. So just have a look at this blue line here. If I go through the scan in XY plane, you can see the blue line moving from right to left, and you can see just where we are at the moment. The same is true here, by the way. Oh, okay. Yeah. Then on the bottom we have the gray value histogram, which also you could see in Geodict 2020. This didn't change that much. You can see on the x-axis the gray values, and on the y-axis the number of voxels which belong to this certain gray value. So you can see that we have a steep curve going up, then we have a slight dip and going to another peak and then moving down again. So these peaks normally represent two phases of the material, the solid material and the pore space. And then we have certain things available which were not available in 2020. So we have a preview in 3D. We have the gray values along the x-axis. We have gray values along the y-axis and along the z-axis. If you want to know more about these histograms and what to do with those, please go to the image processing workshop, and there these will be discussed in details and detail, and also a lot of things more which we are not able to discuss here because we want to do the analysis and not only the image processing. Still, on the top we have some buttons which we didn't use so far. What is interesting is the overlay. You can go to the drop-down menu here and say, I want to see none. Then you see just the gray value image. So you have just the gray values, just the scan as you know it, and as it looks in 2D. Can also scroll through it. But you could also go to segmentation, and then you can see the threshold or the segmentation as it would be done at the moment with a chosen threshold. If you choose the visibility slider and move it to the very left, you can see again the gray value image without any overlays. And if you go to the very right, you see only the segmentation as it would be. And if you have something in the middle, you can see both at the same time. You can also choose outline. Then you see just, if you scroll into this with a mouse wheel and hitting control at the same time, you can see where the threshold is being chosen at the moment, and if this fits to your intuition. You can scroll out again and choose uncheck the outline so that you can see everything again. One very neat thing new in Geodik 2021 is the workflow manager. If you check this, everything that you do is being recorded here, and you can save it in a separate file and rerun it later on, maybe even on a different scan. This is also something which is being shown in the image processing workshop. What we are going to do now is first cropping the image by going to image size, going to crop, and then we choose here 450, and for the upper value we choose 950, and the same for the Y direction. We don't crop in Z direction, and then we click, and then you can see here this neat yellow box just showing where we are going to crop. So this inner part here will be the structure that will be left if we click apply now, and that's what we are going to do. So here you can see we are left with the inner box. Now we go to the segmentation. Just as a hint, there are a lot of image filters available down here. Special filters for FIB-SEM images, special filters for CT images, also general filters. And all of these are being discussed in the image processing workshop. So if you want to know more about these, please go to that workshop. It's really recommendable. What we are going to do now is only segmenting the image. We unfold the image segmentation tab. Then we choose here, just for the purpose of visualization, we choose as the method the manual threshold. And just zoom a little bit into the structure, please. So here you can play around with the visibility again. Maybe we can turn it a little bit down so that we can see where the image, the original image, is below that. And then just play around with the threshold a little bit. You can see that if we go to high, we are left with very few solid material. So here you can see that there's a lot of things that should be solid material, which are at the moment segmented as poor. And if we go to very low values, you can see that a lot of what is poor is actually segmented as solid material right now. And with a manual threshold, you can just choose yourself where this should lie. And you can also see in the gray value histogram how this changes. So usually you would have one peak on the left-hand side of the threshold here, marked by this line, and one peak on the right-hand side. But if you play around with the threshold, you can see that this line just moves and is not located in the middle, at least, of these two peaks. Okay, In our case, it's very useful to choose an automatically chosen threshold, which would be the Otsu in our case, because you can see that this makes sense. It chooses a very reasonable value for the thresholding, and also here. And also it gives you a certain objectivity to the threshold you choose, which you wouldn't have if you choose it manually. In our case, this makes sense, and what we do now is we create a segmentation out of that, already knowing that our volume fraction of the solid material will be 52%, and the porosity will be 47%. So we create the segmentation right now, and then a result file pops up, just summing up what we just did. We used the Otsu method, we used not really image filters, but only the cropping. We have some structural information, the size of the structure, porosity, voxel length, just a short summary of what we did. And this file is called eth_nmc_cathode.gdr. And also the structure that we just created, the segmented structure, is being stored with this file in a separate folder with the same name. And you can always load this structure by hitting on load structure. Not necessary at the moment, it's already loaded. We can close this dialog here and just have a very quick look on the workflow manager. If you just check this, you can see that we have the change image size, so the cropping being recorded, and the thresholding, because that's what we did. We didn't do anything else. And then we can close the dialog here by clicking on Close Dialog. And we are back in Geodict. And this is what it looks for you probably. So we have a structure being shown in red and overlaid with a gray value image being shown in gray. What we just have a look at now is what does our project folder look like. So if you go here to the project folder, right click on it and say open project folder, the project folder opens, and you can see that the structure that we just created is stored here in the project folder. It's called eth_nmc_cathode, and here's also sorry, that's the result file. And there's also the the folder corresponding to the result file with the same name. And if you go into that, you can see that the structure that we just created is being stored here. So this is the result file. We can open it by drag and dropping it into Geodict, and the result file we already know opens. We will close that again and close this. We don't need the gray value image anymore, so we are going to delete that just by right-clicking on gray value image and say discard image. Yes. So we end up with a structure, a segmented structure, which is shown in red right now. Let me change something so that it looks the same as for you. So this is what it looks for you right now, I imagine. So if you want to change it to some nicer colors and a better look, please follow my steps. You go to this little icon here and just click on it with the left mouse button. And then you have the option of choosing different colors for different materials. We only have material ID 0 for the pore at the moment, and material ID 1 for solid material, which is NMC in our case. So if you want to change the NMC to something more pleasing, we can choose a different color and it changes. And maybe we will stick with gray for this workshop. And then we can close the dialog and are satisfied. What you can see now is we chose the box renderer at the moment in the structure tab. And if you zoom into the structure with your mouse wheel, you can see that it looks a little bit like several Lego bricks being put together. And this is just because for every voxel, or every voxel is colored with the material color which corresponds to its material ID. So here we have NMC being colored in gray. And this is very useful if you really want to know where your structure starts and ends. But if you want to have a nice visualization, you can choose another renderer, which is not the box renderer, but for example the smooth renderer. And then your structure looks nicer and smoother. So what we are going to do is now we are going to name our material NMC, because at the moment it's called solid. But if you hit on this little icon here with the left-hand side, left mouse button, you can choose a different material by clicking here on material ID 1 and entering a name here in the information, just NMC. Okay, and then click run. And you can see here it's called NMC now. Still there's something missing, because in the scan it was not possible to see a binder, a carbon black and binder domain, due to the reflection values of the materials. But we know that there needs to be some carbon black and binder in the scan. So we can model this manually into the structure. And we do that just by going to Model, choosing Grain Geo. Then in the Grain Geo drop-down menu, go to Add Binder. Then click on Edit. Here, for the solid volume percentage, add 3%. And then the binder material that will be added in material ID 2 with green. And everything else we leave as it is. You can also add binder in an anisotropic way, but we are not going to do this now. You can choose a binder distribution, for example, but this is more complicated. We're not going to do this right now. Click OK and generate. So again, a Geodict result file opened up, which says how much binder we wanted to add, how much was realized, and the resulting error of that. Again, it's possible to load directly the structure using this button here. Not necessary, because you can see already in the background it's already loaded. So we close this GDR file, this result file, and have a look at the structure, which is very nice. We have NMC here, we have the carbon black and binder in green, and just if you want to see how this distribution of the carbon black and binder looks like, you can uncheck the NMC here in the visibility tab and see that there's how the binder looks like. And if you want to make it visible again, just recheck this little checkbox, say close, and we are fine. This is actually the structure we are going to work with in the next parts of the workshop. And before we're going to the break, we are just saving this as an image because it looks so nice. Go to File, Save Image As, choose a preset. For example, you can choose high definition, and you have the opportunity to crop all the empty space around the structure that you don't need and save it with a transparent background, which is useful if you want to embed it into a PowerPoint later on. And you say, OK. Then Geodict asks where to store it and what to name it. And the first place where it wants to put it is into the project folder. And I just recommend to leave it here and call it NMC with CBD face. So, and it's called as a PNG per default. You can change this, of course, and click Save. If you go to the project folder now, oh, sorry. Not select project folder, but just open project folder. You can see that here the image is being stored. Ta-da! And with this, I think we have deserved our break, and we will see each other in 10 minutes.